morning, students. So we'll start with the chemistry portion of the APSC. Yesterday we were dealing with the matter around us. So we dealt with the 8th standard chapter with what was the questions. Today we'll be dealing with the 9th standard matter around us. You had a matter, I told you earlier also, matter is from 5th you are learning. As you move to the higher classes, the concepts goes on increasing. So yesterday was the portion dealt out what was there for the 8th standard. Today we are going to deal with the portion which is concerned to the 9th standard, that is matter around us, which you have earlier read in the class. So first part of the question, today's question you had, look here, matter is not continuous. Matter is not continuous, but options, A option, particulate, B rapid, C random, D none of the above. None of the above. See, what does this indicate? Matter is not continuous. The word continuous indicates that here something which is not discrete. That means the things are not in particular discrete. You cannot separate out the things. When you see the answer here, you have already learned that matter is not continuous means it should be a particulate. This indicates that it is made up of particles which are frequently in the motion. It reveals, or it is in the form of a minute separate particles. Matters are made up of molecules. Molecules consist of an atom. That means these atoms are in the, they are not constant. Is it? They are always in the motion. If you take solids, the molecules in the solids vibrate, is it, in their own places. But when you see the liquid, due to the intermolecular space, they move. In gases, due to the more intermolecular space, you can see the movement. That means they are particulate. They are not continuous. Next question you have. When we add sugar to water, when we add sugar to water, the particles of sugar disappears. The particles of sugar disappears. Because they A option are very small, B option get into the space between water particles. C are moving. D are colorless. Just think it over. What might be the answer over here? When you add sugar to water, when sugar is being added to a water, it forms a saturated solutions. Because you know that the size of the particles here are less than 10 to the power of 9. As the particles are very less, you can see a homogeneous mixture is being formed. So when you add a sugar to the water, the particles of the sugar disappears. Of course, they get dissolved in water and they get disappear. What is the reason behind it? They are very small. Yes, we agree that the particles are very small. We feel that A might be the right answer. But as per the thing, they get into the space between the water particles. So the right answer is that they get into the space between the water particles. Why do they get into the space between the water particles? As the size of the sugar, if you take sugar or you take a salt, they form a homogeneous solution, is it? As the sizes are very small, they get into the space of the water. Water is in the form of a liquid. Sugar and salt are in the form of a solid. That means solute is being added to the solvent. What happens as there is intermolecular space between them? These solutes get dissolved or get adjusted in the space in the water particles. That is why you can see they disappear. So the right answer is that they get into the space between the water particles. Are moving or colorless is not the answer. This is the right answer. The reason because the size of the solute are very small enough, and as there is the intermolecular space in the liquids, they get adjusted in the space between the liquid what we have got. Next question. Which of the following do not exhibit? Which of the following? Which of the following do not exhibit diffusion? Option A, sand. B, oxygen. C, water, hydrogen. Water, hydrogen. See, to understand this, which of the following does not exhibit diffusion? You should know what is diffusion. Diffusion is that a substance gets diffused or mixed with the other substance, and this mixing is done due to the motion. That is, movement of particles are held responsible for it. So, diffusion is nothing but spreading of the substances, or you can say mixing up of one substances with the other substance, and this is only possible due to the motion or the movement of the particles. So, diffusion is seen in the case of solids, is seen in the case of liquids, and also seen in the case of gases. But the diffusion in the case of solid is less. Why is it less? Because in solids you can see the molecules are compactly packed. Then you can see the movement is not so easy. Because of that, which among the following does not exhibit the diffusion? The movement of particle is very essential for mixing. As they are compactly packed, the movement is not possible. You should identify which among them is a solid. If you see sand, it is in a solid state, so diffusion here is not possible. In case of oxygen, oxygen is a gas, water is a liquid, and hydrogen is a gas. Where you have got an intermolecular space where the movements are possible. Is it clear? So this is sand which is existing in the solid form. The diffusion is not possible here. Next. Larger volume of CNG. Larger volume of CNG, compressed natural gas in short, is available in small cylinders. Is available in small cylinders. Small cylinders. To us due to the property of which property which is helpful to compress the natural gas. First one, high inflammability. High inflammability. High inflammability. B, easy availability, easily available or availability. C, highly compressible. D, low density. The question says, larger the volume of CNG is available. See, larger volume of CNG is a compressed natural gas, sometimes full form also will be asked out, and available in smaller cylinders. See, we have got small cylinders where gas is being compressed out. The main reason is that the answer is highly compressible. Gases can be compressed. Why are gases compressed? Because of the intermolecular space. The space between the gases, intermolecular space in the gases is very high. So when you low down the pressure, what happens? You can bring the molecules very close together. And that is the reason, because of its highly compressible nature, the larger volume of CNGs can be collected in a smaller cylinders. Is it clear? And here the important thing, you should know the components. See, the main component of natural gas is methane. The main component of LPG is butane. Even this also will be asked out. Butane, which is filled in the LPG gas cylinders. And it is one of, and always make a note that first four members of the organic compounds are gases, and all gases can be compressed only because of its larger intermolecular space. Okay, this is the thing. The right answer is because it is highly compressible. The next question. Yes, it is related to the last question itself. Sixth one and also fifth one. Gases are liquefied. Gases are liquefied. How can you liquefy the gas? Under A option, very frequently asked in the examinations. High pressure, high temperature. High pressure, high temperature. B, high pressure, low temperature. C, low pressure, high temperature. Low pressure, high temperature. D, low pressure, low temperature. Low pressure, low temperature. So just now I was talking about in the last question that gases can be compressed. How are gases compressed? Related to it. See the questions based on this. We have seen there is variation type of asking question differs here. See, when you lower the pressure, when higher pressure is being applied, the right answer is high pressure and low temperature. When you apply a pressure, what happens due to the more intermolecular space you get, when the pressure is being applied, what happens? The molecules get compressed. When the molecules get compressed, what happens due to the low temperature? See, if the temperature is high, then there is kinetic energy. That means kinetic energy is the energy which is in the form of a motion. When you increase the temperature, the movement of the particles also increases. When you lower the temperature, what happens? It reduces the kinetic energy. Is it clear? So, higher pressure brings the molecules very closer. Okay. Due to low temperature, what happens? You are reducing the kinetic energy. And because of this, you can compress the gases can be liquefied. The gases can be liquefied, At a high pressure and low temperature. Higher pressures bring the molecules very close together. At low temperatures, you are reducing the kinetic energies and which makes the molecules remain very close together and can be collected in a cylinder or can be liquefied. This is the right answer. High pressure and low temperature. Next one. Which one of the following changes represent sublimation? Yesterday also we have seen, but here the way of asking question is different. Which one of the following changes represent sublimation? Changes represent sublimation. A. Solid to liquid. B. Solid to gas. C. Solid to liquid, liquid to gas. Solid to liquid, liquid to gas. D. Liquid to gas. See, this is one of the things yesterday we have seen what is examples for sublimation was being asked out. They gave few of the examples and asked you which among the following is an example for the sublimation. So we took an example like burning of camphor. Camphor is in the form of a solid. When camphors are being burned up, it directly gets converted into gas. That means solid is getting converted into gas. This is sublimation. In sublimations, the solids are converted into gas with skipping the step of liquid formation. Is it clear? So, even the same question, see regarding sublimations, examples may be given to identify which is a sublimation reactions, or they may give you an example for the example of sublimation and ask you what type of a change it is, whether it is a physical change or a chemical change. Yesterday we have looked about the burning of camphor, and we saw that burning of camphor is an example for a physical change. Why it is a physical change? What happens when solids are getting converted into gas? Liquid step is being skipped out. That means it is only converting from one state to another state. Here the properties are not changed out. If it has been converted into a liquid, then it would be a chemical change. So, based on this, several questions have been asked in different form. So here, sublimation is a process where solids are directly converted into gases. So this process is called as a sublimation. So you should come across with few of the examples for the sublimations and also try to know what type of a change it is, whether it is a physical change or a chemical change. Right? I hope this is quite clear for you all. Then let us move on to the next question. Evaporation of materials takes place. Evaporation of material takes place. See, based on evaporation, you have got various types of questions. Few of the questions will come across one by one. Evaporation of metals. If you want the substance to evaporate, the options given are above its boiling point. Above its, BB stands for boiling point. In short, you can write down above its boiling point. B option, above its melting point. Melting point. C option, below its boiling point. D option, below its melting point. Just think it over which might be the right answer before I give you the answers. See, when we are talking about an evaporation, that means the state of matter here, it is in the liquid state. Liquid evaporate, is it? You should know that the state of matter is in a liquid state. Okay. So when the molecules in the liquids have got different energies. Liquid is water. What are liquids? Water, if you see, water is a mixture of two substances, that is hydrogen and oxygen. Liquids can be anything other than water, can also be a liquid. So the molecules in the liquids have got a different energies, and you know that the properties of liquids are that they are in motion, they flow. When they flow, the molecules in the liquids collide each other. Is it clear? When they collide each other, what happens? Some of the molecules gain energy. That means due to the collision, what happens? They achieve higher energies and allowing them to evaporate. The reason is that due to the movement of the water molecules or due to the movements of the liquids, what happens? The molecules present in the liquids collide each other. Collide means collision. They bombard each other. When they bombard, what happens? These molecules will gain energy. When they gain energy, what happens? This gives a chance for them to escape out in the atmosphere due to the higher energy provided. That means it comes under excited state, more energy. Like when a ball is moving, when you push out the ball moves still faster. That means the rate of evaporation increases. So the right answer for this, you can see, it is below its boiling point is the right answer. Below its boiling point means boiling point of water is 100 degrees. Below its boiling point, the evaporation of materials takes place. And evaporation of materials takes place due to the collision between the molecules, which provides an energy, and that energy helps the substances, liquid substance, to evaporate. Right? Then next question: the fluorescent tube. The fluorescent tube and neon gas and neon gas bulb and neon gas bulb glows because A, presence of charged particles, B, high density of gas, C, high temperature, D, high applied voltage. Just think it over, what might be the answer? The fluorescent tube and neon gas glows. Why do they glow? See, when you talk about the fluorescent tube, in case of fluorescent tubes, due to the low pressures, it is due to the low pressures, the presence under the low pressure, what happens? The presence of Hg vapors. Hg vapors are nothing but the vapors of mercury, which emits UV rays. They emit UV rays, and which helps the fluorescent tube to glow. That means at the low pressures, the mercury vapors emit UV rays, and which which results in the glowing of the fluorescent tube. When UV rays are being emitted out, indicates that they are being ionized. They get ionized. What are the when are they getting ionized? See, the property of metal is that they have a delocalized electrons. Is it clear? Delocalized electrons are free electrons. Due to the availability of free electrons, the condition is that they are good conductors of electricity. Metals are good conductors of electricity because of delocalized electrons or free electrons. And when these electrons, when they ionize, the electrons are being produced out, and these electrons help the production of UV rays, and which helps the fluorescent tubes to glow. But in the case of neon gas, what happens here? When does the neon gas get give out the electrons? What is to be applied here? In the case of neon gas, when a high voltage is being applied out, high voltage, when you pass the current at a higher voltage, these neon gas gives out, there is a flow of electrons. At a higher voltage, when a current is being passed out, and as you know, neon is an inert gas, is it? When a high voltage is being applied out, there is a exit, the electrons are given out from the things, and there is a flow of electrons. This flow of electrons emit light, is it? And that is fine. See, why does fluorescent tube and neon gas bulbs glow? In both the cases, you can see they are ionizing, is it? This is under the low pressures. The mercury vapors get vaporized. Here you are applying a high voltage because as it is an inert gas, you have to apply the more voltage, and under that conditions you can see there is the flow of electrons, and this flow of electrons helps them to emit light. Now looking at the options, you tell me which is the right answer. The fluorescent tube and neon bulbs glow because presence of charged particles, high density, high temperature, high applied voltage. But in both the cases, what is common? You can see there is a flow of electrons. That is, they are having a charged particles, and these charged particles are held responsible for the flow of the thing. That is, it is due to the presence of charged particles which help them to glow. Understood? How these charged particles are being given out. Next one. I hope these things are being clear here. Ninth question. Which of the following decreases? Which of the following decreases the rate of evaporation? See, I told you based on evaporations, you have several questions. So each and every time you can have a few other options, and which makes you to think of. See, if you want an evaporation to take place, the factors affecting the evaporation is the temperature is very essential. Is it? Temperature is required, wind is required, surface area is very essential. Even this can also be asked as an option. We can give you an example. Factors affecting the rate of evaporation are surface area, then wind or air, temperature, all the above. Then all the above will be the right thing. Same question with the different options they are given here. A option, you have surface area, humidity, C, temperature, D, wind. See, when you look about the things, I have told you the factors which affect the evaporations are surface area. If the surface area is larger, the rate of evaporation will be very high. Even